Okay, so if you have a compound, let's say a compound is determined to contain 1.71 grams of carbon and 0.287 grams of hydrogen. Determine the empirical formula. So how am I going to go about this?
You need moles.
I need moles. That is correct. So where am I going to start?
You take what you have of carbon, what you're given.
Take my given of carbon, and then how do I change that to moles?
So you have to take your mass of carbon.
What is the mass of carbon?
Was it 12?
So I'm putting it at the bottom, I'm assuming. I'm just writing.
Yeah, because they have to cancel because you want moles. So the moles will be on top.
Okay.
You better get my calculator. $14.3. No, yeah, 14.3.
14.3? This is a 1, I'm sorry. This is a point.
Oh, I didn't do a decimal. Hold on, my bad.
That's all right.
Okay.
So 0.143?
Yeah.
Okay.
Sorry.
And that's moles?
Yeah, of carbon.
Okay. So, and then?
Do the same for hydrogen.
So I have to do hydrogen. And what is the molar mass of hydrogen?
1 point something.
Let's see. Who's here? Abby. Are you there?
Yeah.
How you doing this morning?
I'm barely waking up.
Well, I know. I'm feeling you right now. I don't know what it is. I know it's hump day. Maybe that's it. It's just hump day. And the weekend was long. That was a long weekend. Did you guys feel worked?
Yeah.
Yeah, me too. So tell me about hydrogen. What is the molar mass of hydrogen? Because Cassie was giving me 1 point something, something, and something. So you're going to help Cassie out?
Yeah.
Okay, so what is it?
I want to say it's 1.
Okay, it's 1. So it's 1 mole. And I get this from my periodic table, right? I'm not just pulling this out of my butt.
No.
Okay, good. I just want to be sure. I know my butt's big, but I can't keep pulling stuff out of it. Thank you, Alberto. So Alberto gave us the exact number. It's 1.008. Good job. Okay, so then, now this is really hard math right here. So that's 0.287 moles. Okay, so now I got the number of moles. Now, again, why would I want to get the number of moles? What are moles? What are moles to us? Amanda, what are moles to us?
Moles. I'm sorry, I'm unsure.
Take a guess.
Moles. That's an atom, right?
So it could be the number of atoms. It can be the number of atoms. There also could be the number of horseshoes or husbands or children, right?
Okay.
So it's just a quantity, right? So when we're talking about moles, we're talking about a quantity. We know that 1 mole is going to equal how many atoms or husbands or boyfriends?
Ooh, yes, husbands.
Husbands, yeah, okay. So how many husbands with 1 mole? So if you have a mole of husbands, how many husbands do you have?
5.
1.
Not 1,
12.
not 12, because a dozen is 12. So 1 dozen is 12 husbands. It's not 12, way too little.
It's Avogadro's number, right?
It's Avogadro's number. What is Avogadro's number?
6.022
6.2.
times 10 to the 23.
That's right. See, Martin, Mauricio, he told us in the chat, he says 6.022 times 10 to the 23rd. So that's how many husbands you would have, right, Mauricio? That's how many husbands Mauricio has, right? I was expecting a chat. Maybe he got kicked out again. Okay, so that just gives us quantity, right? Moles is a quantity. Okay, so when we're doing relationships, when I'm talking about, let's say this formula, C2O, right? What does that tell me?
2 carbons, 1 oxygen.
That means I have 2 carbons and 1 oxygen. Isn't that quantity?
Yes.
Okay, so we want to try to put in quantity so that we can do a comparison. Okay, so that's the reason why we want to get it to moles. You guys see that? I know it's early and the coffee has not kicked in yet, but we'll get there. We'll get you there, okay?
Is that, Dr. Henry, is that where you were saying you can only compare like apples to apples and oranges to oranges? So it's the same thing because like you can't compare grams to moles because they're opposite?
Exactly, yeah,
Okay.
exactly.
So the 2 for the carbon and the 1 for the oxygen, that's the mole?
Yeah, so we would say we'd have 2 moles of carbon and 1 mole of oxygen. Or we could just say, number-wise, we could have 2 atoms of carbon to 1 atom of oxygen. They're going to be proportional to each other, right? Do you understand that?
Yes.
So all you're doing with multiply, if we said moles, you're just be multiplying it by Avogadro's number if you want the total quantity. So there's a direct relationship between it, a direct ratio. Okay. Okay, so now we're able to sit there and set up some ratios. So how would I set up my ratios? What would I do to do that?
You divide by the smallest number.
Okay, so let's divide by the smallest number. Let's see, if I'm correct, and I know it's still early and my brain may not be working, but I think 1.43 is the smallest number.
Yep.
So I divide both of them by the smallest number.
Yep.
So it'd be 1 and 2, right?
The bottom one, Dr. Henry, you said you gave us the stuff for like decimal if we need to round it up.
Yep.
When I divide the bottom one, it's 2.00 and then different numbers. Do you want us to just leave it at 2?
Yep, because that's really, really close to 2. If it's 2.5, then what would we do?
Round it
by
to 3.
2.
We would round it to 3
Times by 2.
times by 2. Okay.
Oh.
Okay, so then my formula is going to be what?
CH2.
Piece of cake?
Yep.
Good, good. Not too hard. Okay, everybody got that down? I can move on?
Yes.
Oh, I'm gonna need another cup of coffee. Whew, that first one did not do the right job.
Drink an energy drink.
Yeah, then I'll be too wired. And then an upset stomach on top of it.
Just drink
Okay.
water.
I have water right here. Yeah. But it doesn't give me that jump that I need. I need like a little volt to get me started. Okay, so it says a compound is a compound is determined to contain 5.31 grams of chlorine and 8.40 grams of oxygen. determine the empirical formula. So what are we going to do?
Find your moles.
We're going to find our moles. So we have, our given is what?
5.31 grams of Cl.
So we're going to start off with our given. Let's see. Darlene, what is the molar mass of chlorine?
The molar mass is 35.45
Okay. So am I going to put that on the bottom or on the top?
in the bottom.
Okay. 35.45. And what's on top? One.
1 mole.
Okay. Who's quick on the draw?
It's 0.1497.
If it's, how many sig figs should I have?
3, but if I round it up, then it makes it 150.
Okay. And that's not horrible, is it?
No.
Okay. Okay. And then what do I do next?
Your oxygen.
My oxygen. Okay, so I have 8.40 grams of oxygen. Gracia, what am I going to do now?
And oh my goodness, I can't even see.
What's
Oh
the
my goodness,
next
I'm not
step?
even sure.
You're not sure? Somebody want to
No.
help Grass? Oh, you're going to tell me?
I'm not even sure. Oh my god, I can't even see. I'm barely waking up.
Well, you got to wake up. Leslie.
You would put 16
Oh, you gotta
grams
put-
on the bottom
Okay,
and then 1 mole on the top.
good job. Okay, so what are we going to end up with?
0.525.
Okay, how many sig figs should I have?
3.
525.
You're missing 5. There we go.
Okay. I told you it was early, didn't I? Okay, so what am I going to do next?
Divide by
the smaller number.
moles of chlorine.
Divide by the 0.150.
Okay, so what do we get?
Top one is 1, and then oxygen is 3.5.
Oh, 3.5. Okay, so what do? It's 3.5.
Multiply both of them by 2.
So we multiply them both by 2. Why don't we round them?
Because you just can't do that.
Because you just can't do that.
It throws off
Exactly.
your ratio.
Exactly. It throws off the actual ratio. So that means I have 2C and I have,
7O.
I'm sorry, CL, sorry. CL. And I have 7O. So my chemical formula is going to be
Cl2O7.
piece of cake.
Yep.
Yep.
Okay. Questions, concerns, Cash? So
No.
you should expect a question like this on the exam. Okay, so this is just the flow diagram for how we would go about doing it. Any questions on it?
No.
Okay. Oh, let me let Mauricio. Mauricio, you got to stop jumping out of the room. Okay. So if you're given the percent composition, what are we going to do then? And how will we use that to determine the empirical formula?
If we are giving the percent, don't we wait, no, never mind. Wait, I think don't we like
We talked about this on Monday.
yeah, I kind of remember, but no, I don't know.
So what is the assumption that we can make if we're given a percentage?
That it's out of 10.
That is out of 10 or out of 100?
100, I mean, sorry.
Out of 100. Okay, so we can assume that it's out of 100 grams. Okay, and
And you
that's the
give it
assumption that we're going to make here. So what I'm going to do is I'm going to put you guys in groups, and I'm going to have you guys work on this problem. Then we'll come back together and we'll work on it. How about that?
Okay. How
many-
long are you going to give us?
I think you guys can do it in about 7 to 10 minutes.
Okay.
Okay. So I'm going to give you 10. And if you need a little more time, I think 10 is too much, but I think you can do it. Okay. Does that fair?
You start by writing down, pretty much converting the carbon and oxygen to grams.
Okay. So do you want to show us? Can you write on my board?
Yes. How do I do that?
You want to hit annotate. If you go up to the top, there'll be either 3 dots or it'll be options. And there'll be
Oh, okay.
Yep.
I'll do the second one. I'll do the oxygen.
Is it easier if I just do this? Do we continue throughout the whole thing, or?
Yep.
Oh, okay. Sorry. For this one. Did you want me to stop here?
After we find the number of moles, yeah. So we'll give another group an opportunity to finish it up for us.
Oh, okay, sorry.
Okay, good job. Good job, good job. Okay, so we have the number of moles, we have quantity. Let's see. Let's see. Let's go with, did we lose Preston? Okay, Gracia and Mauricio, what are we gonna do next?
Are you going to convert the ratio of moles
So
to the
what do you-
lowest number?
So I'm gonna divide by the lowest number. Okay, so which one is the lowest number? Smallest number.
Mm, Let me
Dr.
see.
Henry,
Is
can you hear me?
And don't forget your
Yes.
units, guys. Because I will deduct you for that. I'm not a mind reader. Okay, so which one is the smallest you said? I'm sorry. And sig figs. How many sig figs should I have here?
4.
4? So I can get rid of this. These two down here.
mhm.
And you're good on your sig figs. Okay. So which one am I dividing by?
4.54?
I'm gonna, is that the smallest number?
Oh no, that's not the smallest. The smallest is 2.272.
Okay. So we're
Divided
gonna divide
by-
by the smallest, right?
Yes, divided by the smallest. And then you would do the same thing in the bottom.
Okay. And our answer is?
The top one is 1 and the bottom one is 2.
Okay. And our final answer is?
CO2.
CO2, yeah. The empirical formula.
Piece of cake?
Yep.
Good job, piece. Oh, poor guy. And then I forget about him in the waiting room. I'm a horrible instructor. Man. I hate this waiting room crap too. It's driving me crazy. So I need to figure out how to change it back. Okay, any questions? No questions? Good. That means you guys got it. Okay. So if we want to determine the molecular formula from our empirical formula, we have to sit there and calculate or have the molecular mass, or what we call the molar mass. And then we divide it by the empirical formula mass. Okay? pretty simple, right? So let's say, for instance, we had let's say we were given on the last problem where we had CO2. CO2 was our empirical formula.
Mm-hmm.
And let's assume that the molecular compound that we're talking about, it has a molar mass of, let's go, 88 grams per mole. So in this context, what is the empirical formula mass? How would I calculate that?
You would take the carbon and then 2 oxygens, right? And then add them together for your total mass.
We have 1 carbon, so that's 12. And we have 2 oxygens,
So that's. Do
32.
you want the full, or do you want just like, do you want the 15.99, or do you want?
You can give me,
just say
you can give
16?
me around it because it's so close to 16 that we can.
Okay. Okay.
So what is that? 44?
Yeah, it's 44.01 grams per mole.
Okay. So in that case, we would take that 88.
Wouldn't it be the other way? Because the 44 is your empirical.
Yeah.
Oh, I'm sorry. I thought you were writing the other way. Sorry.
And we're going to divide it by our empirical. And that gives us what we need to multiply CO2 by, the number that we need to multiply it by. So then that would be 2. So the actual formula, or the molecular formula of that compound would be
C2O4.
Correct. Piece of cake?
Wait, Dr. Henry, where did we get the 88 from?
So I'm giving you that. That would have to be given to you.
Oh, okay.
Okay?
Okay.
Will the molecular always be given, or is that something that we would need to figure out?
The molecular would always be given.
Okay.
Okay, a compound has an empirical formula of CH2O. And its empirical formula mass is equal to 30 AMU. And a molar mass of 180 AMU. Calculate the molecular formula. So what am I going to do?
So you take the 180 divided by the 30. That gives you 6.
Okay. And then what do I do with that?
Multiply it to your CH2O.
Okay, so I multiply this all by,
So C6. H12.
okay,
6.
so I get C6,
H12O6.
okay, piece of cake.
Yep.
Kayla, you're there?
Yeah.
Yeah. So pretty simple, right? Not too hard.
Mm-hmm.
Yes.
Yeah.
Okay, so let's move on to something new. So an autopsy found 291.3 grams of an unknown compound containing carbon, nitrogen, oxygen, and hydrogen in Mr. Dredd's bloodstream. After isolating the compound, the composition was determined to be 49.48% carbon, 5.15% hydrogen, and 28.87% nitrogen, and 16.49% oxygen, with a molar mass of 194.19 grams per mole. Find the molecular formula of the unknown compound. Okay, you guys up for it?
Yep.
Okay, I'm going to put you guys in groups, take a picture of it, and then you guys come back. We'll see who comes up with the right answer. Okay, how long do you need?
How do we
5
do the
minutes?
save? How do we do the save thing, Dr. Henry?
What was that? How do you do the save thing?
Yeah.
You go to annotate and you hit save.
Whew, okay, I was freaking out.
And then it'll say, it'll give you where you can find that at. Because it puts it in a really obscure folder.
Okay, thank you.
So
Yeah.
we're going to make groups of, let me recreate.
Dr. Henry, what's with the white stripe?
What white stripe? Or at the bottom?
No, it's in the middle.
It's in the middle. I don't know. Let's see.
What happened to the screen?
Maybe turn off
Is
your
it-
screen share.
Is
and
it
turn
normal
back on.
now?
Yeah, it's good.
Yeah, no?
Yeah.
Yeah, it's good.
Okay. Okay. So, who's going to share their skills?
I have a question before we do this.
Okay, I may have an answer.
Okay, so we have to find the empirical formula with the percents of the elements. The molar mass, does that play a part in it, or is the molar mass just to put, that's just a given that we put into the molecular formula equation?
That would be the given that we put into the molecular formula equation.
Okay, so like if you're doing the percent for carbon, you would just use the 49.48,
Okay.
right?
So, yep, you're just going to use that.
Okay. We were confused on that part.
Okay.
Dr. Henry, I just want to confirm, when you are writing out your empirical formula, when do you multiply it by 2 so it doesn't throw off your number?
When you're writing out your
When you have to round up?
So, no, remember that table that I gave you on Monday?
Oh. Okay. Hold on.
So if you have a number that ends with 0.2,
Multiply by 5.
you're going to multiply it by 5. If you have a number that ends with 0.333, you're going to multiply by, oops, I got carried away. You're going to multiply by 3. That's right. If I have a 0.25, what am I going to multiply to make that whole?
4.
And if I have 0.5,
2.
and if I have 0.66, so we're not putting a sign of the devil there.
Thanks. I don't like that. That one was, I wrote it written down. That one was, wait, 3, right? Again?
Right. Let's do it again. Yep. And if I have 0.75,
4.
and then if I have 0.8,
5.
okay? Piece of cake?
Yeah. Yeah. Sure.
Okay. Okay, so what team is offering?
Do you want us to start with the finding the ratios?
Sounds good.
I'll annotate one of them if somebody else wants to do another one so we can go faster.
Like per group or just your group, Maddie?
I don't care, whoever wants to. I'll start with carbon if someone wants to do another one.
I could do oxygen.
I'll do nitrogen.
So we got oxygen, nitrogen. Who's going to do carbon and hydrogen?
I'm doing carbon.
You're doing carbon? Okay.
Mhm.
Is anybody doing nitrogen?
Sounds like you.
Okay, I'll do that.
I was doing nitrogen.
Oh, you were? Okay.
Yeah, sorry, it wouldn't let me get out of it.
Nope, it's okay.
Which one are we missing then? Oxygen?
I'm doing oxygen.
Oh. Oh, I need to delete that. And then we divide by the smallest number.
Okay. Sounds good to me.
Are we doing this one? I'll do this one too. Oh, she did it. Cool.
It won't let me, like, yeah, it's trying to do it so y'all can read it.
My eraser went away. What the heck? There we go. Hey, Dr. Henry.
Okay, let's take a look. Okay, and then your empirical formula is going to be,
C4H5NO2.
okay, and then your molecular formula is going to be, well, can you type that up there so we can see it?
Yeah.
Good job, good job. And don't forget to put your units on the exam, because I do give partial credit in case you do crazy stuff.
Are you talking about mine?
Yeah, or whoever was in blue.
That's me.
That's you? Yes. Yes, I'm talking about you.
I'm just that advanced, Dr. Henry.
Mm-hmm.
Okay, so this is our thing, but the numbers are in subscript. And then,
Am I blind? I don't see anything. Oh, I see
did it
it.
pop up now?
Yeah, I see it now.
Okay. So
Okay, so then your empirical formula, your molecular formula.
you do 194. I'm typing it. I don't know if you could see it.
It after you hit enter, will show up. It's usually a little delay.
Oh, I clicked it. I don't know how to go back in. But don't we have to find the mass of the C4H5?
That's right.
Okay, so where's my thing? What do you want me to label it for the empirical formula mass?
Oh, just the part here. So then we'll know what you're talking about.
No, when on the molecular formula that I'm writing out at the top, what do you want me to label the mass of the empirical formula?
Well, you don't know it yet, so you just put the units. You want to just make sure you have the units.
It's not this, the 97.
Yeah, so it's, oh, I see what you're saying, but it's also going to be grams per mole, right?
Okay. I don't know how to do that same one, so I'll just do this. G slash mole. Okay. Can you see it?
Yep.
I'll do this one too. All right, time for the calculator.
It's pretty much 2.00, Maddie.
Okay. So that's our answer, Dr. Henry.
Okay. So the final formula is what?
2.
It's C8H10N4O2.
Okay, type that down so we can see it.
Okay, hold on.
So if I'm asking you for a formula, you're going to give me 2, I'm going to mark you wrong.
I
Just
thought
so
you meant our
know.
answer of our thing.
Okay.
There you go.
Okay. Piece of cake?
Yep.
Okay, good. Okay, so this is a good stopping point. Are there any questions?